Where did we stop in the last class? I think only you two were there. You saw the lecture? Okay. So where did we stop last class? Which page? Do you remember the page? We did gravitation, right? Which page? Okay, which question we did? Last. We completed that? Okay, so 16, 17. Okay, let's do this quickly. 16th question, I think we've already done. Question 1, similar to question 1. Okay, 16th is already similar to question 1. Then let us look at question 17. A piece of iron sinks in water, but a ship made of iron floats. Okay, so what is the principle of flotation? What is principle of flotation? What kind of object floats in water whose density is less than water, less than density of water? So if density of substance is less than density of water, it floats. Okay, less than or equal to. If density of substance is greater than density of water, it sinks. This is the principle. Okay. Now, piece of iron sinks in water because its density is more than water. But ship made of iron floats. Why it is so? Yeah. Piece of iron sinks in water. Whereas its density is greater than density of water. Okay. But what about ship? However, ship floats, ship made of iron floats. Why? Ship made of iron floats because what about density? What about density of ship? So if you take a piece of iron block, and if you take a ship, what happens? So when iron block sinks in water, so what is the upthrust on it? By Archimedes principle, it will be equal to weight of liquid displaced by it. Okay. So that is going to be less than the weight of block because density. What is weight? Weight is mg of this block. It will be volume of iron block into density of the block. Okay, and g. Then how much weight of water it will displace? It will displace weight of water m dash. Let us say this is mw. So mg is this. This is the weight of block, and mwg is how much? Volume into density of water mg. Now this is density of substance, correct? Which will be greater? Which weight will be greater? The weight whose density is more. Although volumes are same. Volumes are same. So if you compare mg versus mg, ये जो substance का mass वाला करोगे, ये 1 हो जाएगा. पता ये कितना आ जाएगा हमको? So for a floating object, this should be equal. If you compare these, okay, which will be greater? Which weight will be greater? Let's say this is W1 and this is W2. Which will be greater? W1 will be greater. So it will sink because the upthrust will not be able to balance it. Okay? But in case of ship, where is the metal portion? It is only at the boundary. Inside is air. Okay? So now let us say this much volume of the ship is inside the water. This much volume of the ship is inside the water. ठीक है? तो उसमें क्या होगा? The ship portion which is inside the water is a bigger volume. Full water will be replaced. Okay? And in the hollow portion, it is not metal, it is air only. So the average density of the portion of the ship which is inside, it is not density of the substance only, it is the density of air also. So the average density of the ship, because average density of the ship is less than density of water. Water. So the weight of water displaced by the ship is more than the weight of entire ship. That's why the ship is floating. Is that clear? Because in flotation, we apply Archimedes principle. We apply Archimedes principle. So what is Archimedes principle? Archimedes principle gives how much upthrust is acting on the floating object. So the upthrust acting on the object is equal to the weight of the water displaced by the submerged portion of the object. So in this case, the weight of the water is more than the weight of the ship. That's why ship is floating. Is it clear? So the explanation you'll have to read and understand Archimedes principle. Come back, ask question if you don't understand. Okay. So reason it a little bit. Okay. A body of weight W units float in water. What will be the weight of the water displaced by? Again, by Archimedes principle, what is the answer? Now this body is floating. When the body is floating, is it moving down? Is it moving down? No. And it says the weight, that is net force downward, is W of the body. So what will be the weight of water displaced by? Weight of water displaced by is nothing but upthrust by Archimedes principle. So for a floating body, upthrust must be equal to the weight. That's why it is balanced. Correct? So whatever is upthrust acting on the body, it is responsible for the floating body. Isn't it? So that's what it is. So what is the answer? Net force must be zero, no? Otherwise, whichever side the force is more, the body will move in that direction. Correct? So if weight was more, body will continuously sink. But it is floating. That means the upthrust must be equal to weight. And what is the upthrust? Weight of the water displaced. Okay? So the answer is weight of the water displaced is equal to W. Answer is W. Same weight. Can you read the Archimedes principle all of it right now? Otherwise, you may have difficulty understanding these questions. Just read what is Archimedes principle. Page 27. Let's discuss the next question if we are done. Any question on question 18? 18 understood? Pakka? Did you give any test at school? Huh? स्कूल में एक भी टेस्ट हुआ कि नहीं अभी तक? How was the result? Huh? Okay, so out of 13 में से 1-3. Okay, okay. Physics part of the questions. Okay, good. What about your? अभी तक हुआ नहीं? If I got 21. Physics part. Then all science. Science. So you don't know the segregation. But you did okay with physics questions. What about you? You told recently 10. 5 out of 7 for the 5 7 marks का test का physics के questions. ठीक है. So this should get better now. Okay. And feel free to discuss questions from your school also. Okay. Wherever you feel difficulty, you can discuss. Bring your question paper. You can exchange papers with each other. Benefit. And you can change question paper. So everybody will benefit. Okay. Why is it difficult to hold a school bag with a thin strap? The strap has a smaller amount of area, so the pressure exerted is higher compared to. Correct. So when you hang the bag, if the strap is thin, okay, it will hurt your shoulders because the pressure generated will be more due to smaller surface area of the strap. Okay. All right. So thin strap has small area. Thus, more pressure will be exerted by the strap. So more pressure will be exerted by the strap. Hence, okay. Why does an object float or sink when placed on the surface of water? We just discussed this question. Tell me now. Why does an object float? The floating or sinking of an object depends on its density. Correct. So it floats when its density is less than the density of water. Okay, it sinks when its density is more than the density of water. That's it. Correct. So density of substance. So we already written same answer as 17 में I had written the principle of flotation. Same answer. Okay, next is question number 21. This is a tricky question. You find your mass to be 42 kg on a weighing machine. Okay, is your mass more or less than 42 kg? So what it is trying to say is, you have a weighing machine. So when you stand on it, it shows 42 kg, right? So is your mass actually 42 kg or less? Or is it more? Is the machine showing the exact mass? That's the question. So when you enter into water, what do you feel? You feel lighter or heavier? Huh? Lighter. Why? Because water exerts upthrust. So are we not in air? Are we not in air, surrounding air? Just like water. So on our body part, is air not working? Huh? So the answer should be less. Sorry, this weight mass displayed is less. Actually, our mass should be more than. Okay. So one way of looking at is if you considering upthrust by air. Our mass will be more than 40 kg. Correct? Because when we enter in water, we feel ourselves that we become lighter. And when we go in space, also we feel lighter. But the problem is, it's a very tricky question. Mass is a constant quantity, it does not change it. But the weighing balance does not show mass, it shows weight, which is calibrated into kg by dividing by the value of g. So even if you go in space, imagine your mass was 40 kg, it remains 40 only. What changes is the value of g. That's why you feel lighter. If you get any answer other than this, like discuss this question among your friends and class teacher. Let's see if they have any different answer. Okay, so just check. The other answer you may expect is mass is constant. Mass is constant, so it will be same, right? But if you consider upthrust due to air, it should be more than 40 kg. Okay. All right. So we have 3 more classwork available. Shall we do it? Let's do it quickly. Any questions till here? Let's do this. So you have a cuboid of sides 40 centimeter, 20 centimeter, and 10 centimeter. Have we not done it already? We have done it. Example 5, page number 26. Same question. We have done 1 and 3. Only the middle part is to be done. Okay. In our, so it is same as example 5. We have done this already. Okay. So you can do it. Then you have 2 and 3 are the questions based on relative density, which is actually not in syllabus. But I have given you the formula. What is the formula for relative density? Relative density is given as density of substance divided by density of water. And density of water is a known constant, where density of water is 1000 kg per meter cube. This you should remember. Now in the question 2, what is given is relative density of gold is given. So we are given RD of gold. What is this? 19.3. Express the density of gold in SI unit. What you have to find out? You have to find density of gold. So density of gold is basically density of substance. So by this formula, since therefore density of substance equal to RD into density of gold. Density of gold will become what? RD is 19.3 into this is 10 raised to 3 kg. Okay, density of water is 10 raised to 3 kg per meter. And relative density is no unit because it is ratio of same quantities. Question number 3. What is given here? Density of mercury. Let's call this as density of substance. What is given here? 13.6 into 10 raised to 3 kg per meter cube. So what you have to do? First is you have to express it in gram per centimeter. So 13.6 into 10 raised to 3. 1 kg is 1000 gram. And 1 meter is 10 raised to 2 centimeter. Right? A meter is 100 centimeter. So how much is this now? 13.6 into 10 raised to 3 into 10 raised to 3 into 10 raised to minus 6 gram per centimeter cube. Minus 3 into 2 minus 6 and this becomes centimeter cube. So what is it? So this is just 13.6. 3 plus 3 6 minus 6 10 raised to 0 which is 1. Ten raised to 0 is any number to the power 0 is 1. 13.6. So relative density, you have to also find relative density. Generally, density of water, if it is not given, you have to remember it is 1000. The substance density is given. What is density of water? 1000 kg per meter. So this will be cancelled. So it is equal to 13.6. That's the ratio. Okay, so with this, we have completed this step. There are different types of questions here, like assertion raising and all, MCQs. So are you looking at these questions yourself? There are multiple choice questions. Are you following the homework rule? So in that you should look at these questions. And wherever you are getting stuck, you can discuss with me. Okay. So try to see as many questions as possible. That will prepare you for 10th also. Because these are the kind of questions that you might face in your school exams. You have case study type of questions as well. A paragraph will be given. Then there will be questions on that paragraph. So with this, we have completed gravitation chapter. You had missed any classes. So do you have any topic where you want any spatial explanation? Both of you. Already got it? Okay, so. Okay, fine. So you've already applied for extra lecture. Extra lecture might be taken by Nancy, but you've taken it before. So yes, just attend. So if there are any doubts, still we'll see. Okay, we can discuss. Okay. So attend the lecture, then afterwards, if you have anything, we can discuss. Now I will proceed with the next chapter, which is chapter 10. Work and energy. Now, let's define what is work in science. It's a complex position is changed to the force and is on this work. Is this started in your school? No, we have studied this in third. Oh, third standard. Okay. So, if I keep some weight on your head, like you are standing with some weight, carrying some weight and standing, are you doing any work? Will you be tired? Then why are you getting tired? When you run, will you be tired? Yes. Because body is at work. When you're holding any weight, still you will be tired. So tiring is a sign that you are undergoing some kind of exertion or you're doing some work. But in science, work is defined differently. Okay, so here we are talking about mechanical work, right? So when we say work, we're talking about mechanical work right now. Wherever the word mechanics or mechanical comes, motion is involved. Okay, motion, mechanics. Okay, so motion is involved or machines. So these are basically moving parts. So suppose you have an object, right, like a duster. When I apply force on it, it is moving. So when the force applied on an object produces a displacement in the object, then that force is doing work on the object. Okay. So let us say some force F is applied, which causes this body to move by displacement S. Then we define work as product of force and the displacement in its direction. Okay, work is defined as product of, that is, work done this is how. Where is the displacement? In the direction of force. Okay. So this is here the force and displacement are in the same direction. Then we define work with this formula. Okay. So we can write work is said to be done when a force applied on the object for this or displaces the object. Okay, work is said to be done when a force applied on the object displaces the object in its direction. It means in the direction of force. Okay. But there may be a situation where the force and displacement are not in the same direction. Right? There may be a situation where force and displacement are not in the same direction. Okay. So how do we calculate work done when force and displacement are not in the same direction? See, there is a very common example of like a traveler bag with a pulley, right? And when somebody is walking, so where is the force applied? Force is applied in this direction. This is the direction in which force is applied. And where is the displacement taking place? Right? Force and displacement are making some kind of angle. Let us say this. This force and this is the displacement. And there is an angle between. Let's call that angle as theta. The symbol is called theta. So in this case, work done is given as Fs cos theta. Okay, Fs cos theta. So are you familiar with what is cos theta, sin theta, tan theta? So it will be introduced to you in trigonometry when mathematics, when you reach there. Which chapter is that? 10. Still some chapters away. Not this year. I think it's in 9th also, right? There will be. No trigonometry this year. So let me tell you what it means. Okay. So some basic. So trigonometry means measurement of triangles. Okay. So three sides of triangle. So for a special case, consider a right angle triangle. So you have A, B, and C. These are the three sides of the triangle. This is the right angle. And let us say we have one angle theta. Okay. So the angle, the side adjacent to the angle is called base. And side, this is called opposite. Opposite side. Or perpendicular. Okay. Or perpendicular. And this is called hypotenuse. So AC is hypotenuse, AB is perpendicular, BC is base. Right? If this angle was here, listen carefully. Right angle is quite obvious. Instead of this, if the angle was here, theta, then BC becomes perpendicular. Always remember, okay? Opposite, the side opposite to the angle is perpendicular. The side adjacent to the angle is base. Is this nomenclature clear? Okay. Then what is sine of theta? It is the ratio of perpendicular upon hypotenuse. It is the definition. Sine theta is the ratio of perpendicular side upon hypotenuse. Cos theta is defined as base upon hypotenuse. Okay, this is how it is defined. That is, this is opposite side upon hypotenuse. This is base upon hypotenuse. Then tan theta. What is it? AB upon BC. What is it? Opposite side upon base. These are the definitions. Okay. So if you look here, Fs cos theta. So you can also write it either Fs cos theta or F cos theta into S. Both are same thing. Right? So what is the meaning of this? What is the meaning of this? What is S cos theta? So if you draw the perpendicular from S on F, okay, let's say this was, we draw the perpendicular. and this becomes right angle triangle. Correct? Isn't it? So what is S cos theta? So if I give this some name, is it S? Let's call this S, this point is G. From here, what is cos theta? So what is the work done? Force into displacement in the direction of force. So what you do is you project S on G. So you will get OG. If you drop a perpendicular from S to F, what is the displacement then? OG. So what is the displacement in the direction of force? OG. How we get it? Drop a perpendicular on force. So what is OG then? So if you look at that diagram, OG is base. Okay. And OS is hypotenuse. So what is cos theta from that triangle? Cos theta is base, which is OG upon OS. OS is nothing but S, let us say. OS is the displacement. OS is the displacement. So what is OG then? S cos theta. So OG is the displacement in the direction of force, which is S cos theta. You get it? Because definition of work done is force into displacement. What displacement? In the direction of force. So displacement in the direction of force is OG. And that's why we get this cos theta. Because you take the projection of S on force, then it makes a right angle. Okay? So don't worry too much about it. It's not in your textbook, but in volume it is given, so I thought I'll explain it. Because in higher classes anyway you will write it. Okay? And then there are different values of cos theta depending upon what angle is there. That we'll discuss in the next class.